This meeting is being recorded.
I love the WebEx sounds. You are muted. Oh, hi, everybody. So just a disclaimer, I am coming to you from the very lovely Norfolk, Virginia part of the country. And at the moment, we are getting hit by Tropical Storm Elsa. And that means it's very windy, very rainy outside. And there is a 50% chance I might lose electricity during this session. So if I just drop off completely, Elsa has let me go. So welcome. I'm glad I'm with you today. This is Real-Time Revolution. I'm going to talk about one of my favorite subjects, SignalR. Before we get really too deep, I want to tell a story. And I want to start with an app. And I actually did a client engagement about 2 or 3 weeks ago where they brought me on and they said, Kevin, we need your help with our notification system. And that's not an uncommon request when I come in and I talk about SignalR with different companies. Because they say, Kevin, we have these two little icons up at the top of the screen. One that tells the user the number of alerts that they need to know about right now, and then the number of unread messages that they have in the system. So these are two completely separate numbers. They're calculated differently, and they need to be updated in real time, especially the alerts, because in that current system, if you were to get an alert, you're competing with other people in your company to respond to it. So think of a salesperson that needs to respond to sales leads as they come in. That alert is mission critical to me doing my job and me getting extra money at the end of the month. So we need the system to be able to go and get the current number of leads, bring it back, play a little sound, and display the number up in the top right-hand corner. And you're thinking, Kevin, that doesn't seem like a difficult thing to do at all. And let's imagine you're doing this work back in 2007, the beginning of the modern internet as we know it today. Well, it would work something like this. You have your client, your app out there in people's web browsers, and you would have your server, which might not look like the one in the picture. And well, every couple of seconds, it would make an AJAX request. You remember that old-fashioned word? Asynchronous JavaScript in XML, even though no one used XML. We'd go back to the server and we say, hey, server, can you please give me the current number of unread messages? And it would do the calculation depending on who you are and say, oh, it's 0 or it's 5 or it's 15. And say, okay, well, that's cool. Well, what if I want the number of notifications? You make another AJAX call, and you probably are doing this on some sort of interval. Well, in my client's particular case, they were making these calls every 5 seconds. Every 5 seconds for both the leads count and also, or the notifications count and the unread messages count. And think about this. You have a single server out there that is getting these requests from one instance of the web server. And as developers, we really think about our apps in terms of it works on my machine. So it works really fast, a couple milliseconds, the response comes back. Every 5 seconds, we're doing that. But we don't think about these applications in terms of the real world. We don't think about the 1,000 active clients that are currently using the server. And they're all doing the exact same thing, where they're all making these requests every 5 seconds. Or actually, it's 2 requests every 5 seconds, but that's in individual tabs. How many people out there just use one tab? They probably have 15 tabs open. So they told me, Kevin, it's likely at peak times during the day, we can get 35,000 requests per minute just to these separate endpoints, because they have people out there just loading a bunch of tabs of their app. And they were working on a way to even try to make the local experience better, where only one tab would go make the request, put it into local storage, and the other tabs would all share that data together. So because you want to keep everything in sync. And he said, this is not sustainable because our application is just peaking itself out by processing all these requests for data that doesn't even change that often. So they asked me, Kevin, is there a better way that we can do this? So everyone out there, let me introduce myself. My name's Kevin Griffin. I'm a 12-time Microsoft MVP, and my focus primarily is in ASP.NET Core, Microsoft Azure, and building really robust business web applications. If you ever want to talk to me afterwards, consult with Grip.com. I would love to chat SignalR with you, among other things. And I'm very active on Twitter at @1KevGriff. On top of that, I'm hawking a product. I have a course on SignalR because it's one of my favorite subjects, SignalRmastery.com. It's hosted up on Udemy, and it's somewhere between $9 and $12, depending on the time of day. So if you go to SignalRmastery.com, that's usually the best price. But everything I'm going to talk about in this session, I cover in much more detail in the course. So we're just going to scratch the surface of what SignalR is. But if you want to get really deep into the weeds, go check out the course because I talk about all these different things. But let's come back to our app problem. What's a better way to solve this issue? We need to update data from our server, but ultimately we don't want the client having to make continuous requests back to the server in order to get that data. Well, there's this fancy product out there fancy technology called Websockets. And you probably have heard of Websockets before. It's not a new tech. We're probably coming close to 10 years where Websockets have been the thing. When I started doing SignalR back in 2013 is when it was released out to the public. WebSockets was still relatively new. Not every browser supported it. Not even every operating system supported it. So if you're running IIS on Windows Server 20, what was it before 2012? Was it 2009? I don't remember. I forgot my Windows servers because it was such a long time ago. Didn't support WebSockets. You had to have 2012 in order to support WebSockets. So we've made massive leaps in WebSocket technology. So what is a WebSocket? It's a one-to-one connection between a client and a server. And this is really useful to us as a communication platform because when something happens externally in the application, we'll just say something happens. This could be a new unread message comes in, a new lead comes in, a lead gets picked up by someone, some external event occurs, our server becomes aware of it, and we've written that code before. Go update the database. Let's put something into our cache. Let's, do this, do that. But along those lines, we can also then tell the WebSockets, hey, send a message to the people that need to know about this lead, or tell this particular person that they have a new unread message in their inbox. We can use a WebSocket to just push that data out to everyone that needs to know about whatever's going on. And yeah, I have a fancy little graphic for that. So we end up taking our original problem, which was I have a bajillion different clients all connected to my server, and I need to send messages to them, but I don't want them continuously talking to me. I just want to have one open pipe between all these clients. And when something happens, eventually, we send that data out to only the clients that need to know about it. All right. I don't like spending a ton of time in PowerPoint. Let's just go into some code. I want to talk through a couple core concepts. If you have questions, just yell at me. We can answer them along the way. But let's go over to VS Code. Let's talk through this for just a moment. This is an ASP.NET Core 5 application running .NET 5. If you're still on ASP.NET Core 3.1, that's fine. If you're still on ASP.NET Core 2, you should probably get off of that because it's not supported anymore. If you're on .NET Framework, the lessons we talk about today apply just in a different way. The syntax is different. SignalR for ASP.NET Full Framework is supported just from bug fixes, but it's not going to get continuous long-term features or anything like that. But everything I'm showing today is still good for ASP.NET Core 2 all the way up to 5. When you sit down and you set up an SignalR application, you really have to set it up in two different places. You're setting up the server and you're setting up the client. So let's talk about this from a server standpoint first. I have this just boilerplate code that I did a .NET New with, and I really didn't have to do anything. SignalR comes in the base package for a .NET 5 project. So you get ASP.NET Core, you get SignalR. There's nothing major that you have to do there. Any good ASP.NET Core developer will tell you have to go into your services and set up your dependency injection, and then you have to set up your routing pipeline so SignalR can handle the requests come in. So let's start with configure services. This is as easy as just adding SignalR injections. There's more complicated things you can do with this. I'm not going to show you that code. The other thing you have to do is you have to set up endpoint routing. So you have to set up where does that WebSocket exist out on the internet? How do WebSockets get into your server? Well, that's done through the endpoint API in ASP.NET Core, and we use a concept called hubs. Now I'm going to talk about a hub in a little bit more detail in a moment, but for now, let's just remember this one line of code that I'm mapping a hub to a particular endpoint or URL that's going to be exposed on my server. Just make sure this doesn't conflict with any controllers or other endpoints that you might have. Let's see. Oh, I just saw a question. Let's take the questions as they come. WebEx, show me questions. WebEx. Just confirming, SignalR uses WebSockets, but what are the advantages of WebSockets over polling or long polling? We will talk about that. I actually have a bunch of slides that talk exactly about that point. So, all right, where was I? All right, so we have our hub. Let's jump into the client code for a second first, and I'm going to come back to the hubs. This is the difficult thing about SignalR is I have to show you A and B, but to explain A, I have to show you B, but in order to show you B, I have to show you A. I know that doesn't make any sense at all. So let's just continue. I have a very simple HTML page. If you are writing JavaScript, you're good to go. If you're writing TypeScript, you're good to go. If you're not writing any web-based language at all, maybe you're a .NET developer or you're a mobile developer. I'm sorry, like a WPF developer or what's the thing all the kids use now? I don't know, whatever that Windows mobile thing is. There's a .NET client for all of you. If you're doing Blazor, you can use the .NET client for SignalR. I'm going to show you the web aspects of it because that's 99% of the use cases that I see when I go into different applications. But this app is really straightforward, and that's a very nice way of saying it's ugly. It's ugly as sin. I have a single text box. I have a checkbox, and I have some other buttons I'm going to show you a little bit later. But our core goal here is we want to build an application where whoever is looking at this page, my text box is always in sync and my checkbox is always in sync, because this is something that I see commonly in a lot of different applications. I've thrown in some other little graphical things that we'll talk about later, but no need for you. You need to install some packages. Now I'm showing raw JavaScript, which is not ideal. I'm expecting most of you out there to use something like Webpack. Webpack is probably the most common, but you need something that can build, basically pull in NPM packages and build them and give you nice, small, deployable units. The one that you want to install for SignalR is Microsoft/SignalR. Now, the reason I'm showing this specifically is because there are two. There's another one called ASP.NET SignalR. Don't use this one. This one should actually have a message at the top that tells you it's no longer supported, but it's still up there because there are legacy systems that rely on it. Don't get confused. Use the Microsoft at Microsoft/SignalR. So this supports JavaScript clients and TypeScript clients. In the SignalR course, we do everything 100% TypeScript. I'm showing JavaScript here because it's much easier to set up and talk through some of the code. The reason for that is when you're in the app, let me go into my node modules. Where is my node module? Oh, it's hidden. Hold on. Oh, because I forgot to npm install. All right, this should only take a moment. All right, I'm going to zoom in, zoom. If you go into Microsoft SignalR, there is a distribution folder in there where they've pre-built the browser version of SignalR that you can just add to your application. I don't recommend this for production apps, but if you're in a pinch or you're learning something new, this works amazingly well. So that's what I did. I did the npm install. I just added my SignalR.js file to the end of my HTML, and you can ignore Toastify. Then I have my own code, which is index.js. Now index.js has some just ID checking, and we have a couple of events set up. So let's talk about what this looks like when it's all running, which it should run. So we'll do .NET run. We'll open it in a browser and boom, you have the world's ugliest application. It says, hi, there's a text box and a checkbox. We want to build an app where I can have multiple versions of this page. And when I type into one, it syncs to anyone else currently connected to this page. So sounds like a tall order. Let's get started. So first things first, we need something on the server that can basically manage the connections to the server and also manage the different messages coming and going. And we call those hubs. Think of a hub in the same way you would like an ASP.NET controller. So a controller, if you're into your patterns and practices, is basically a single purpose way to organize your code. I'm creating something here called a sync hub, and it's basically going to sync two pages together. One thing that you don't want to do in SignalR is you don't want to create multiple hubs. And it's kind of an anti-pattern, right? Because I'm just told you it's like ASP.NET controllers, but you would have a couple dozen ASP.NET controllers for a whole bunch of different topics. You don't want to do that with hubs. And I want you to guess in the chat why. And you'll probably see as we start going through some of the code. But there's a very specific reason why you don't want to have multiple hubs. But a hub works a couple different ways. You hide these because we don't care. A hub is just a class that inherits from a SignalR hub. This is what we use when we go into our startup and we tell it, I want to map an endpoint to a hub. SignalR underneath the scenes is going to do all this managing of different WebSockets that are connecting. It might handle server-sent events. It might handle long polling connections. It's going to do all this black box management for you, but it's going to umbrella all these connections as a sync hub. We could, right now, go into our app into our JS file and come up here to the top and tell our web page when it opens for the first time, we want to create a new hub connection. So I'm using the SignalR object. I get that because I have brought in the SignalR JS file. I'm going to tell it to create a new hub connection builder. The hub connection builder, they're trying to build off of C# isms where everything's a builder and eventually you build it at the end. But I'm telling the hub connection builder, I want to connect with the URL hubs/sync. Now notice that this matches the same hubs/sync that I have in my startup CS. So I'm telling you what the endpoint is. What's interesting about having this as a magic string is this could go to a completely different server. You have to worry about cores if you do that. It could go to a different servers altogether. And we've done that in a couple of cases. But you just tell SignalR, this is where you go to connect. You might have a development server versus a production server. You might have a server for scaling or that's standalone. For our purposes, we're just going to give it the local relative address of hub/sync. And some other cool things you can do in here. Let's see if IntelliSense works with me. It is not. But you could tell it to turn on automatic reconnection. Yeah, IntelliSense isn't working. You can also use it to turn on logging if you care about logging. There's a couple different options that you can use here. So we're just going to tell SignalR, I want to connect to hub/sync, build that connection. And I'm not going to do anything else except come down to the bottom and tell it that I want to start the connection. We're not doing any communication between the client and the server. We're just telling it start the connection. Give that a save. Let's see, I closed my browser. We'll open the browser back up. And I'm going to bring up DevTools. I spend a lot of time in DevTools. All right, let's do a refresh. It didn't connect. All right, what did I skip?
Was it meaningful that that one slash was red?
No. Which slash is that?
Down by your index.js. Bottom of the page.
It shouldn't be, but you know what? Let's do that. If that's it, I'm gonna eat my hat. That was it. Son of a.
I developed today.
Oh my gosh.
I'm a SignalR developer.
So you know what's amazing is I was running this on another machine, identical setup, and it worked fine. Like it worked absolutely fine. The problem is that
environmental issues are always the worst, aren't they?
Yeah. All right, let's fix that.
So while you're doing that, could you take just a second to speak to, for people that have had no exposure to SignalR, what the best use cases are? I mean, you would choose to use SignalR for what kind of communications versus other kinds?
I will talk about that. Actually, I have that as a topic.
Okay, all right.
Yep.
Well, then I'll leave you to it.
Yep. All right, so let's go ahead and clear my stuff here. Yeah. So that was my that was the symptom, was it wasn't loading any of my JavaScript, and it's because I did the include wrong, and I guess this version of Edge didn't want to read it. But the version of Edge on the laptop I built the demo on does. I don't know, it's weird. All right, very long story short, I start the connection and SignalR does two things. It first normalizes the URL, so it makes sure it's connecting to a valid URL. We can see localhost 5001 hub/sync. Because if I don't give it a domain, it's going to just figure out that I want to use my current domain. And this is a step called negotiation. So first thing SignalR is going to do is it's going to talk to the web server or the server that it's running on and say, what's the best way for us to talk to each other? Is it WebSockets? Is it long polling? Is it server sent events? We're going to talk about the differences between them here in a second. But most cases, it's going to say WebSockets, and it creates a WebSocket between the client and the server. And we can actually see that in our network sources. So if I open the network tab and go to WebSocket, these were the two before I refresh, but I have one here that's pending. It's just open, so it hasn't closed yet. I can go to messages and we can see, let me make some room here. This is just SignalR doing heartbeats to itself. So if you've never used a WebSocket frame in the network tab, you have messages that are going up to the server, and you have responses that come down from the server. So green and white. When we start sending real messages, we'll see this populating with all the content that we're sending. So let's talk about this concept of protocols for just a moment, because I think there was a question about that earlier. There's a couple different protocols when we talk about SignalR. There are fewer protocols now than there were when SignalR came out for .NET Full Framework. The first most obvious one is WebSockets. And WebSockets, everyone's pretty familiar with this, where every individual client opens up a single WebSocket connection back to the server. And if you're running in a load balance scenario, this is going through a load balancer to one of N servers that you're currently running. But these are continuous connections that don't go away. They don't close unless you physically close them or if something happens to your network connection. So they are long-lived for the entire lifespan of your application. Next, you have server sent events. Server sent events are they're a Netscape era technology. So if we go back to the mid 90s when Netscape was at its pinnacle, server sent events was created as a mechanism where a client could send an initial request to the server telling it, I would like to set up what's called an event source. And the server creates this pipe back to the client that works in the same way as a WebSocket does, with the exception that it's one way. So the server is the only thing that can use this pipe to send data down to the client. It's basically an AJAX request that never closes, ever. It's only the server that can send data down to it. The drawback here is if the client needs to send data back up to the server, it's making additional requests. Third, you have this concept called long polling, and this is the fallback of all fallbacks. Every browser going all the way back to IE6, if you had to support that, God help you if you do, they all support long polling. And this is the one that people really know and is what most folks would write if they had to write something on their own and didn't know how to write native WebSockets. But the idea is that the client opens up a request, an AJAX request, to the server, and it leaves that connection open until the server has something that it wants to send back. So the server says, oh, I have a new message, or there's a new unread message. I have an open request from the client I want to send the message to. I'm going to send the response back on that pipe. Well, when that happens, the connection closes and it resets itself. So we go back to where we were before. It doesn't really save you too much because eventually these connections are going to close themselves anyway. So if you open the long poll and nothing gets sent back within a 2 to 5 minute period, it's going to close the connection and reestablish itself automatically. And the 2 minutes, that really depends on the browser. Also depends on the individual browser settings. Some browsers, you can set this up to 5-10 minutes. Others, it can be as low as 1. It really depends. So just a quick comparison. So if you come back and look at this later, WebSockets always available. You can use them. Cons, and this was actually a question in the chat. Socket pool exhaustion when you have multiple tabs and users. This is a problem, but this is a good problem to have, and you have to have thousands and thousands and thousands of connections to exhaust your connection pool. And a lot of this is determinant on how much memory that you have available on the server that you have. I have exhausted connections before, but I have exhausted connections on an Azure app service where I was running, I think, 1 or 2 nodes, but it was a single app service plan. So we didn't have all that much we were working with. And I had accidentally set up a procedure where I was opening I had 5 hubs, and each hub establishes its own connection. I exhausted the connection pool. Fun. Server-side events, it's a good fallback if you don't have WebSockets. The client can't use the event source to send messages up to the server. It still has to do AJAX requests. And then long polling works everywhere, but it's horrible. It's like doing the 5-second connections that our scenario before was talking about. So let's talk about sending and receiving messages. I am so bummed that I spent so much time on a dumb error. But let's talk about how do we set up our sync where when we type something in the box that it gets sent up to the server. So let's go into our code and let's talk about our text box first. So our text box has an ID of text box. Okay. If we go into our JavaScript file, we can see I have a reference to text box. I already have its ID. I have already set up the event listener that listens for the change event. And now I could change this to like input down. Yeah, who cares? Change event. When that happens, I want to go to the server. I want to go to the connection. I want to tell the connection, I want to invoke a method on my hub that we're going to call sync text box. And when we invoke this method, I want to send it a parameter of whatever's currently in the text box. So invoke, you give it the name of the method you want to call and any parameters that you want to pass along. Now this can be a standard variable or standard type, so string, integers, you name it. It can also be complex type, so if you want to send a full object, that will get turned into JSON and then set up to the server as well. There's no real limitation on what you can send here. As long as it's serializable to JSON, you're golden. So we'll say invoke the sync text box method that will exist up on our sync hub. So then if I go over to the sync hub, I'm using regions, don't use regions. And I've created a method called sync text box. So sync text box, the names are the same. That's important. And the parameter that it takes is called text. That doesn't matter. What matters more is its position in the method signature. So position 0 needs to match position 0 of the parameters that I send in. One other thing to keep in mind is if you're sending a parameter in here, say you send a string, but you tell your method that it's an integer, SignalR is going to try to cast that as best it can. If it can't cast it, it's going to fail and you'll get an exception. But it's going to do its best to cast to whatever properties you have in your method signature. So I'm just passing in text, simple. I want to take this text and I want to turn around and send it out to anyone else that's connected to my application. Well, because I'm inheriting from hub, there's a couple little helper properties that I get by being a hub. And one of them is called clients. And clients is, let's think of it as like a dictionary of, not a dictionary, it's like a bag. It's a bag of everyone who's currently connected to my server. And I can go into this back and tell it, I want to send a message to all the other connections in this application. So that's what others means. Now, if I open up IntelliSense, let's see how good it is. So I have caller, I have all. All is one of the more used ones because all is exactly what you think it is. Let's send to all the connections out there. So all these other connections, I want to send a message, or I want to tell it to execute a local event that will also call sync text box, but I'm still going to send a parameter along with it, so it's the text. But this magic string matches an event on the client. So let's go back over to the client again.
Wait, Kevin, before you switch back, sorry.
Yep.
I noticed that there's a type case. You're using the uppercase sync text box in C#, whereas everything is lowercase. So it's not case sensitive then? Or?
It's not case sensitive. It'll figure it out for you.
Terrific. Thank you.
Yeah. I do it just because it's just
style.
personal style. Yeah. Because this is what I'm expecting it to look like over on the client. So now if we go into the connection, which I haven't written yet, so I can come in and tell it, all right, on what we call it, sync text box. I want to get a callback, so it'll get the text. And when that happens, I want to get the text box, and we'll set the value to text. So SignalR uses the same syntax as every event handler that you've ever written in JavaScript using on. And I just want to make sure that the names match. So sync text box matches sync text box. But also notice how they call it the C# method sync text box. And the invoke method on the event handler for the change event uses sync text box. I try to keep some of this stuff consistent because then you're less likely to screw things up. At least on the C# side, you don't have to do it this way. There's actually an easier way. We'll talk about that at the end when we're just BSing. All right, so let's assume I did all this correctly. Yeah, let's assume. I'm going to refresh, and I'm going to open another tab. And I'm going to put these side by side. Now let's assume I say Kevin, and it failed. So let's go see why it failed. It failed because method does not exist. Oh, I didn't restart the server. That's a very obvious reason why it failed. Actually, now that I know it works, I should just do .NET Watch. All right. All right, so let's refresh both sides. Let's do a very quick connection check. Make sure our connections are up. They are. So I'm going to type Kevin. And when I hit enter, notice it says Kevin over on the other side. And then I'll go to the other side. I'll type in Steve and hit enter. So that change event hits. The event handler for the change event says, okay, well, the value is now Steve. All right, signal connection. Call sync text box on the server, pass it Steve. The hub picks it up and goes, okay, well, everyone else, the text box is now Steve, sync text box. So they all get the same event. I did this for 2 servers, but if I open up 4, now notice they don't automatically sync. I don't have code written for that, but if I say Bob, they all say Bob now. Sally. They all say Sally. So they're all in sync with each other. And it's like 2 lines of code. All right. Let's show one more example. Let's wire up the checkbox because really that takes no time at all. I already have a fancy sync checkbox. This one passes in the Boolean instead of a string. And that's the biggest reason why I did this example, is I wanted to show you that it works for any type that you want to send. And then on the server, I'll just uncomment the checkbox, and I'll come up to the top. I'll copy and paste some code. Say sync checkbox. Actually, that shouldn't even matter. So instead of text, we'll just say val. And instead of text box, we'll say checkbox. We'll say checked is equal to val. And val is going to be true or false. Assuming I did all that correctly, I'm going to do .NET watch run now. Okay, so let's close all this. Let's do some refreshing. All right, so what should happen now is if I check the check, you see it automatically syncs no matter what side you're on. So cool. All right. I want to talk about clients for a moment, because this is another place where people have a lot of questions, because there's a lot of flexibility when you decide who should get a message. And we're talking specifically the hub talking to individual clients. The first one I want to talk about, so let's use this example. I have a server and I have a variety of clients A through F. When I say clients.all and I make a method call and pass in some parameters, this is pretty straightforward. I want to send to all connected clients, A, B, C, D, E, F, G, so on. They're all going to get the message, server method name, and whatever parameters I want to pass. Sometimes when you make a call, so let's say a client sends a message up to the hub, and the hub wants to respond only to the person that made that original request. Well, this is done with the caller, basically it's like an enumerable of different connections. So I want to go back to the caller and they get the message, meaning no one else does. So the client A sends a message to the server only responds to client A. What we just saw in my example, I used others. So others works kind of the opposite. Client A sends the message to the server, but the server then sends a response to everybody else. Now you can get really wonky with this if you want to. I don't use these particular methods because I think they're cumbersome. If you were in the call earlier when Steve and I were chatting about connections, when we talk about individual connections, they're basically all identified by what's called a connection ID. Now, a connection ID is just a GUID or GUID or whatever you want to call it, a unique identifier. I'm using C, D, E, F as my unique IDs. When a client sends a message in, I want to respond to everyone except individual connections. I can do that with the all except method call. Now, I really have never had any reason to do this. I'm not sure. I'm sure it exists for reasons, but I've never used it. I don't know anyone that has used it, but it exists for some reason. Sometimes you want to send to an individual client. So if you know the connection ID of the client that you want to send to, you could tell SignalR, well, send an event to an individual client, and it will do that. Don't do this. Like, just don't. Because it's like a lot of things in .NET. Just because they let you do it doesn't mean you should. This is something you shouldn't do. I have a very long blog post that talks about why you shouldn't do this. You could send to a group of clients. So if you know a bunch of connection IDs, you could send to very specific people. Again, not something that you want to do, even though it's available to you. If you're using identity, so ASP.NET Core Identity or something that has an I principal, you can actually get a client based off of their principal name. So let's look here. You have A, B, C, D, E, F with different usernames. So I could tell SignalR I want to send to the user Kevin, and it's going to look for every connection where the user is Kevin, and they get the message. You can also say multiple users, Kevin and Sally. So Kevin and Sally, we all get the message. Then there's a special set of calls called groups, but I want to show you a demo first before we get into that. Oh, we have some chat. Kevin, talking about connection limits, how many connections are available using the SignalR solution? That is dependent on the resources of your machine. SignalR has some very high limits. If you have the RAM for it, it will keep taking connections for a while. RAM is your biggest limiting factor for a lot of these cases. And I've actually talked to folks on the team trying to get like an answer out of them, and they give me the classic, it depends. It depends on how many resources. If you're running it on an Azure app service and you're only using the smallest node available, you might only be able to do like 3,000 connections. But if you're doing like a P2 or P3 that has a solid chunk of RAM associated with it, like each individual node that you run on that machine could probably do tens of thousands of connections. If you need more scalability than that, there's things like the Azure SignalR service that will actually offload the connection management for you. And we can talk about that afterwards if you want to. Steve, the connection ID is an ID for the connection and not the user ID. That is correct. So if I'm Kevin and Kevin has multiple tabs open, each individual tab has its own connection ID. And the reason I don't like using connection ID is because if I refresh a tab or a window, I get a new connection ID. So it's a lot of work on you as the developer to manage those connection IDs. There's a life cycle for a connection, but it's a lot to manage. Where it's easier to use what I'm going to talk about now, and that's groups. So let's go back into our demo. I'm going to show you another technique as well. You might have noticed this in my startup. I had a commented out section here called add hosted service. So if you haven't used hosted services in ASP.NET Core, you should. They're awesome. I created one called New User Worker. And what New User Worker does is on an interval every 10 seconds or so, it is going to go to the random user API, which is free if you've never used it before, and it gets a random user data. And it's going to pull that data and basically turns it into JSON. And I want to take that object and send that object down to all my connected users, or actually only the connected users that want to receive this message. So somewhere in here, I have a to-do. So you notice if I look down here in my in the bottom, I have a 10-second delay. I should actually take that out. Let's do a 1-second delay. Oh, there we go. So we zoom in. And you can see here, .NET Core telling me, oh, I'm making the GIT request, I'm making the GIT request, and so on. So it's going and getting these users. On my page itself, you notice I have start notifications and end notifications. And that's because I want each individual page to be able to opt in to whether or not they get these new user updates. So let's look at the JS. And let's look at the click event for the start button and the end button. And both of these are going to send calls up to the server telling them I want to start notifications or I want to end notifications. And they'll pop up a little toast telling you, giving you some feedback that notifications have stopped, started or stopped. Now up on the server, so in my sync hub, I have more regions. Let's show you what these client-side methods look like. Start notify and end notify. And what these do is they add my connection. So the connection being whichever tab I'm opening. They're taking my current connection ID and they're adding me to a group that's, again, it's another magic string called notify me. Now this can be named whatever you want it to be named. As long as I'm in this group, any message ever sent to the group notify me will get the message until I'm taken out of the group. So let's go into our new user worker, and we need to actually show you two different things. First, how do I use a hub context outside of the hub? So I'm not in the hub right now. How does this class know how to talk to all my connected clients? Well, the part I haven't showed you is up here at the top. Through the magic of dependency injection in ASP.NET Core, I can inject what's called an iHub context, called sync hub, and this will give me a reference to everyone currently connected to my server. So I store that away for later in a field. So as my to-do, I should be able to say hub context dot clients. Actually, I don't want that. Yeah, I want clients dot group. And what was the name of my group? Notify me. And this will only go to connections in that group until I want to send async. What's the name of the method? Well, the name of the method is going to be, I have not written the method yet. So let's write the method. We'll just say new user, and it'll be, we'll say new user is the object passed in. We're going to copy our toast, and we'll say welcome. This should be new user dot name first. I think we'll see. All right, so on new user, I want to pass in that user object. Now this is going to send in a full object. If I mouse over R, you can see it's class new user because I'm doing mapping from JSON into a user object. So that full object is getting sent out to my event handler. Notice I have squigglies because I forgot to await this call. Everything inside of SignalR is async awaited. If you forget to await, you will have problems. Remind me to talk about that. I had a client dealing with this a couple of weeks ago. All right, we'll pass our object in and refresh, save. All right, let's assume this works. Let's open up let's open up another one there. Okay, refresh. Let's just do a quick test. All right, test. All right, so I'm going to hit start notifications here. Let's wait. I think it's every 10 seconds something happens or should happen. Should be every 10 seconds. All right. Let's look. Let's see. All right, so it's going through. Why? Let's connection on new user. Just do. So now let's do some creative debugging. Let's go look at our. Oh, all right. So new user. Oh, I see what I forgot to do. So this failed because this is not a valid object. All right, I screwed this up. I forgot that R is there we go. I need the first result. All right, that's my fault. Start notifications. All right, you see it pops up there. Let's open up another. All right, so I'm going to start notifications in this second tab. So now what should happen is every 10 seconds. Oh, I forgot to refresh and reconnect. Duh. All right, sit back, wait. I need to turn that duration down or up a little. 1,000 seconds. Let's make that 5,000. Okay. So now we sit back and we wait. Every 10 seconds, a new user will be generated, and we can see we're getting that notification between these two different apps. Now this third window down here at the bottom, it's connected. We can see that it's still updating everything, so the connection's not broken, but it's not subscribed to those events. It's not a part of that group. Now I can end notifications in any of these. And now we sit back and wait. And only the one tab gets the notification because I've unsubscribed from the events in the others. So this is a great use of groups. So if we talk about this in a little bit, clear graphics. Here I have a group of yellow and orange. So if I tell SignalR, go get the group orange and all the connections in that group, emit this event for me and send these parameters. I could say, get everyone in the group except a particular connection. Again, don't do this. I don't like this. But you could if you needed to. So everyone in orange except E. You can also specify multiple groups. So if you need sales and marketing, if you need the East Coast and the West Coast, you can have all these different groups and they all get the message. Now you could also segment this a little bit deeper. If A sends the request and you want to respond to everyone in the group yellow except A, it's others in group. Again, something I've never used, but it's there in case you need it. This works really well. And this kind of leads me into a discussion of what is this? How does this work in the real life? Let me show you one of my favorite examples of SignalR. So I have a client. It's a very public client called LiveCAD. LiveCAD is based in Ohio. And what LiveCAD does is they do 911 aggregation. So there's a lot of individual counties in, I think they're in Southern Ohio, where they have firehouses. They're all volunteer firehouses. And sometimes it's, when you call 911, it might be more beneficial for a fire truck or emergency services in a neighboring county to respond to you than it would be for services in your own county to respond to you, just the way that counties are divvied up on a map. So how do you keep track of all this stuff? Well, we build LiveCAD to basically pull 911 data from a couple dozen different 911 agencies in Ohio. And we build them into what we call configurations. So this is a configuration that shows aggregated data for a handful of different 911 agencies. And this is useful to me as someone working in a firehouse because I can see what's currently going on in basically zones I care about. And thankfully, we're doing this at night, so it's not too busy. Sometimes I'll load this view and there's a dozen things going on. The worst thing that you would see on this screen right now is it would flash red. And red means something really bad is happening and it needs my immediate attention. I came into this project years and years ago. It was built on top of ASP.NET Full Framework, web forms, and they were using an update panel to refresh this page every second. And if you've never had to use an update panel before in web forms, it's what it does is it renders the entire page, sends the entire page down to the client. The client only updates the section inside of the update panel. Actually doesn't even sound all that bad because it was magic. The problem was that all the logic for CSS and building out these configurations was done in the database. And the database was hosted on the same server as the web server. So this poor web server is 100% CPU all the time, where they said we can't bring on more agencies anymore because there's seizure. All right, it's not flashing, so it's not bad for these folks. Dispatch, you kind of watch it. It's updating in real time. And so before, when it was in the update panel, we would get information would come in from these different agencies, update the database, but the clients were all going back to the database every second to get the new data and re-rendering the entire view over and over and over again. So this system just couldn't keep up. God forbid you restart the app because it would take it 10 minutes to actually get to the point where it could start servicing calls again because there's just so much traffic trying to get into the server. So we started from scratch. We rebuilt the entire system onto SignalR, and we built it where when we got updates from these individual agencies, different 911 agencies, we would figure out which of these configurations should know about the update. And there's a set of rules that dictate that. And then I have groups for every individual connection or configuration. So if you log in and you are looking at Ohio 25 MEC 3, well, when I send a broadcast to the group, Ohio 25 MEC 3, only people looking at that group will receive those messages. And they're all deltas. They're individual changes in the data. So here a moment ago, we saw the incident up here at the top. It went from no status to dispatched. Well, that was a single delta for that incident. What I didn't do was send the entire status of this configuration. When this happened, we went from 100% CPU utilization down to practically zero. The server was running, it was managing the connections. It just didn't have much to do because it wasn't having to rebuild these configurations every single time. So the best story I have of that, and this was published in a magazine for firefighters and all that good stuff. There was a firehouse in Ohio where so the volunteers were in the firehouse and they were watching LiveCat, and LiveCat started flashing red. And red means we need your attention. And they look up and it's someone's house is on fire, someone's going into cardiac arrest, and they go, all right, that's us. They start suiting up, they get in the truck, the door to the firehouse opens and they are pulling out of the firehouse. And at that moment, as they're pulling out, the dispatcher comes on to notify them of the call that they need to go to. LiveCat was faster picking up the new incident and notifying them of it than the human who put the call into the system was. So if you think about it, we're probably talking the difference of 20 to 30 seconds, at most probably a minute or two, where the call is coming in 911, it's put into the system, and the dispatcher notifies the fire or the emergency services that they need to go do it. Well, if you have ever had a loved one that has had like a heart attack or a seizure or allergic reaction, that seconds could mean the difference between life and death or more complications down the line. So because of a technology choice, we have effectively made a solution that could potentially save lives, because we are notifying the emergency services about emergency needs faster than physical, like actual humans can do. So when I tell that story, I say I've written software that saves lives, because that's exactly what it has done in several cases. So that said, the number one use case for this are people that like to listen to police scanners. They pay to look at this data, and because this is basically police scanners in the year 2021. So this is one example. I have a variety of clients that use it simply to do similar things that we were showing here. When you're typing into a box, you need to sync that state across other clients. So I was working with a client 3-4 weeks ago where they were dealing with this problem. They have a variety of logs, basically, and you can type messages into the log, but you need to be able to reflect those changes across the entire application whenever anyone else is looking at it. Well, it's just a simple matter of, well, send the message up to the server that something has changed. The server determines who should know about it, and it sends those changes down to everyone individually. So as long as the clients are connected, you have essentially, I'm not going to say it's message guaranteed delivery, but it's very likely that the messages are going to go out the way you expect it to. So the reason they called me is because the messages weren't going out reliably. You would type something into the box, you would see the server get the message, but the clients it was sending the message to would never get the message. And it turns out the problem was that they were not awaiting their calls to SignalR. So they had conveniently or inconveniently forgot to await the calls. And what was happening is that the requests were never completing all the way. So it would start to do the work and the request would never complete. So the individual clients would never get the messages. They went in, added some awaits. Everything started working magically. I have one client where we actually wrote a chat app for them. So the rule with SignalR demos is you're not allowed to write a chat app because chat apps are really boring. And they're also way more complicated than you need them to be for different use cases. But I have a client I've written 2 or 3 chat apps for, basically embedded in their business system. It works really well. But there's no like grand like use case that SignalR is exceptionally good at. It's simply, how do you sync the state of your server with all your individual clients? The most common question I get is, does this replace RESTful services? So if you're doing Ajax now, do you use this to replace Ajax? And the answer is no. Ajax is really good, and Ajax is like guaranteed deliverability to an extent. If you make an Ajax call or say HTTP call to your server, you're guaranteed to get a response. Now it might be a 400, 500 timeout, but you're guaranteed to get that response. In SignalR, you're basically using a pipe and you're throwing a football in, and you know it's likely that football is going to end up where it's supposed to go. But I mean, there's a case where that could not happen. So you don't get an acknowledgement that the message has been received, that it's been processed, and everything's good to go. You get that with RESTful services. So I try to tell people, don't use SignalR for, let's load the entire state of the app. Let's use SignalR for maintaining the state of the app. So change notifications, that sort of thing. That said, there's been a couple times where I use it for very quick, get the details for this, delete this user, delete that. If it's a really quick call, it's kind of up to you. It's whatever your style is, but I don't think it doesn't replace RESTful services. I think that's a smell if you think, all right, let's replace all of our RESTful services with SignalR. But that's it. I could go deep into anything. I've been talking a lot about it, but that's why I have the course, because I have learned just through my professional consulting work. And this is a very old screenshot because it's not 27 students anymore. It's we just broke 800 students. And there's a lot of different use cases for SignalR. We haven't touched scaling. We haven't talked about Azure SignalR service. We haven't talked about, there are more advanced topics that we could dive into, but I'm hoping that this kind of scratched an itch for you, that if you were interested in just real-time web developments using WebSockets or other protocols, and you're doing .NET, that you could just jump into SignalR and make your apps real time. So I am happy to answer any questions that you all might have out there.
So,
Steve had a
fantastic talk.
Let's see. What does Steve say? Technically, this allows alerts to go out while they are still on the phone with the person that you help. Absolutely. Yep. Because it's a machine automation at that point. So I apologize for the dumb snafu there at the beginning. That totally threw me off, and it wasn't supposed to. Oh wow.
That makes it easier to learn.
Yeah.
No doubt. We'll run into the same things.
I planned all that.
Yeah, it was a great talk. I can think of a number of apps that we're using right now that I'd love to gut and replace some of it with SignalR.
Yeah. Andre has a great question. Does SignalR use JSON under the hood? By default, it does, yes. It can also use message pack, which is like, it's like compressed JSON, which is it's a smaller payload. It's a little bit more efficient. There are a couple small issues with it, just depending on your use case. But if you're not worried about payload size, just regular JSON is fine. Then you bring up Grpc. Grpc is very interesting because it's new. It's accomplishing kind of the same thing as SignalR is doing. My worry at the moment is just support. It's kind of where WebSockets was almost 10 years ago, where they're still figuring this stuff out. So I'm not going to say it's an apples to apples comparison. It's more like an apples to pears comparison. Grpc and and WebSockets, really. But great question. Yeah, and then in the Grpc stuff, I need to spend more time on as well. Talking connection strategies, how many do we have? Polling events. How many strategies do we have? Infinite strategies. Are you talking about how many connections do we have? So it's we kind of talked about this earlier. It's dependent on the resources of the server that you have. So if you have more resources, more RAM, more CPU, you can handle more connections. What most folks do is they don't worry about how many connections an individual server can handle. They'll scale the number of servers. So, and there's another thing we didn't talk about, but it's in the course. We talk about scaling strategies. How do you scale SignalR? And there's two ways to do it. There's you can self-host your scaling with what's called a backplane, and that's supported on Redis cache, and that works extremely well. I use it for two clients where it's more cost efficient for us to run Redis server or Redis cache than it is to run the other alternative, which is the Azure SignalR service. The Azure SignalR service will take all the connections off your servers and will manage it for you. The problem is you pay per 1,000 connections. And if you are running into a scenario like we have, where at our peak, we need between 6,000 to 7,000 connections at any one time, you're actually talking like a couple $100 a month in bill for these connections. If you have a cost sensitive client like I do, every dollar counts. So it's cheaper for us to run everything on Redis server. But I talk about that in the course. I'm not trying to push everyone in the course, but go buy the course because I talk about all these things. Andre, you're talking about the connection types. I think I answered your question. If I didn't, please clarify. Doug, isn't gRPC more point-to-point as opposed to broadcast? I think so. Again, gRPC isn't something I've spent a ton of time with because I don't see a lot of people in the .NET community talking about gRPC. I see more folks over in the Google community talking about it, which makes sense because it's they're the ones that kind of created that standard. Andre, course uses .NET Core. So the concepts transfer to full framework, but full framework is using a legacy version of SignalR. It's not supported anymore. It works, but it's not supported. So a couple of things we talk about in the course, which I wish I had time for demos. I have, what if you have SignalR running up on a web server and you want to connect a non-web app to it, so a .NET client. There's a .NET client that can talk to your hubs, and so what I have is a console app and a web app both talking to the same server, and they both receive the same messages, and they basically can talk to each other without any code change, no code changes on the server. Have I looked into
That's pretty cool.
SignalR working in Maui Blazor WebView? I have not committed to Blazor being a real thing. I don't want to believe that Blazor is a real thing. And I say that as a person who almost dove into Silverlight full on. I'm just resistant. I think Blazor has come much farther than anyone had expected it to, but there's also there's full SignalR support there as well. But when you're doing Blazor, you're using the .NET client for SignalR, and it works perfectly fine. So, not saying anything bad about Blazor. I'm just resistant to it because I have been very heavy web. I've seen that hurt of Silverlight and Flash, all that stuff back in the day. I'm just don't get your hopes up, people. Just
All right. Any other questions?
Yeah.
Before we take it off of recording? All right, I'm going to go ahead and shut down the recording real quick. Thank you. That was Kevin. That was a great talk.
Yeah, I had fun.
Makes me excited to go get back to SignalR and do some more experimenting.